Hey friends, I'm going to ask you to leave the programming or the ego that we've attached to the formula that we were given for the curvature of the Earth. Now, the reason I say that it is incorrect is because a trick has been played on us. And I think I've worked it out. I don't know that I've answered all of the questions. I'm still looking for input, useful comments, and contributions are most welcome. Remember the phrase, to control the opposition, to lead the opposition, to control it. The best way to control the opposition is to lead it. Well, we're the opposition. And how do we know that the 8 inches is per mile squared is right? Because obviously our reality, we see level and understand level water, and flat, horizontal, and all of those sorts of things. We understand that. So when we say it's 8 inches per mile squared, we have nothing. We look out there and we say, well, eventually, if we were on a globe, eventually it would start to curve and curve exponentially rapidly. And I know that the formula at 4,000 miles away from the, say we're at the North Pole, 6,000 miles away at the equator, is going to give you the requisite amount of drop from the point of the observer. But I think the point of the observer perspective, angular resolution, height of observer, and well, I think these things have been seeded to us as the deception. Because in a reality that was a globe, the perspective of a viewer would have nothing at all to do with the nature of the shape itself. There's a dartboard there just over my shoulder. Would it make any difference to the shape of that dartboard if I was standing on it 100 meters above it, a mile away from it? Would it make any difference to the nature of that thing? No, absolutely not. And the same is true with the nature of this supposed globe lie, reality, or fiction. The amount that the globe curves has got nothing to do with you and nothing to do with me as an observer of it. It is a fixed sphere reality. I know that deGrasse Tyson and co can call it an oblate and say, oh, it's a little puffier in the lower section and so on. They can make up anything that they want. And back in the 1960s, it was a perfect sphere. Today, it's something else, and it's getting bulgier and changing and so on. So they can say anything they like, but the truth is that working on the basis of it being a sphere or an oblate spheroid, it's a rigid, fixed body or shape, and that shape will not change. Its curve or its degree of curvature, it will not change it depending on where I stand. I accept that when my head is on the floor on a racetrack or a bowling green, I won't be able to see as far down the bowling track as I would if I was standing at 2 feet, 6 feet, 10 feet tall. We understand the resolution of the angular resolution, and the perspective of the viewer. But I think the perspective of the viewer, you standing at point A and imagining point B off in the distance has been used to hoax us, now mislead us, and to diminish the truth about the dimensions of the globe as presented. The globe as presented is a 4,000 mile radius and a 24,904 mile circumference. So all I'm trying to do is to work back to, well, what would the circumference be, or what would the amount of drop be for that shape? And the uncomfortable figure, which even flat earthers don't want to accept, which is again how our ego can be easily programmed, is so huge. The amount of curvature is so huge that we would be able to notice it over the distance of your garden, over the distance of a home swimming pool, and so on. We would be living basically on a slope, and it would be a constantly bending slope. And I'm going to go into explaining why it needs to be that, and how we can unpick, firstly, the 8 inches per mile squared deception, and then recalibrate to consider how it might be the case that for every 10 units of distance out, I need to drop down 6 units. And let me just stress that it's not, this is where I think we've gone wrong with our graph paper, is that we measure out 10 units this way, 10 units this way, and 6 units like that. We're not actually describing the journey of the ship. The journey of the ship needs to be 10 units this way and 6 units down. I'm talking in very rough terms right now, but just to give you a sense of that, which would mean that over a 100-meter racetrack, for example, you would expect to see something like 60 meters of curve drop. Someone said to me in my comment section, I appreciate the comment because it's made me think about it, but if that were the case, if it was 10 and, if it was a 0.6 ratio of drop, 1 for 0.6 ratio of drop, then you'd be able to fly around this globe in 10 minutes. Not true, because you're thinking in terms of a very short radius. With a 4,000 mile radius, you've got to imagine a piece of string 4,000 miles long from the epicenter, from the fulcrum, I think you would call it. Perhaps that's not the right word, but from the center of the core, or the molten core of this imagined globe, you've got a 4,000 mile piece of string. And that 4,000 mile piece of string needs to be kept taut the entire time. And it needs to then inscribe a circle. And you'll notice that the circle never becomes more or less steep depending on where I decide to start it from. It's always the same. It's always the same amount of curve. And the same is true with that dartboard there. The dartboard has exactly the same amount. We know this is obviously common sense. And people are thinking in their minds, no, but go back to the point of the observer. Go back to the point of the observer. The problem with using the point of the observer is that is not actually describing reality in the first instance. And in the second instance, when the observer is asking me to observe something 10 miles away, it has nothing at all, the amount of curvature on that board has nothing at all to do with how far away I am when I observe it. My perspective on it may change, and if I go far enough away, I'll say I can't even see a circle. I can't even see the board. If I zoom too far away from it, it may all start to look level. So it's not to do with my observation. It's to do with the reality. Because if I'm asking you to observe a ship at 3 miles, a rocky outcrop at 10 miles, or this is the Black Swan video that's gone so viral, which is the drill rigs, the oil rigs, I think off California coast or somewhere. Those are at 9 miles or something like that. If you're asking me to observe that, the amount of curvature over 9 miles has nothing to do with whether I'm standing on the beach, whether I'm standing on the cliff top above. So, Wick Dest, no, what's his name? Mick West. His obfuscation of, your observer height and so on. I think that's just got us to kind of dig in even deeper and entrench this idea that it's 7.98 inches or whatever. Again, I accept that the lower I am to the surface, the less far I can see across it. I don't have any issue with that. My issue is that your point of observation bears no relation or has no impact on the amount of curvature that the Earth is going to experience if it's a 4,000 mile radius. So, to move on from that, let me give you an example, as I have done I think once before now, to say that if I was to take a pontoon on water level and float 10 pontoons out from a harbor, from the beach at 1 mile intervals, and I'll put a friend I trust and love, I'll put a friend on each of those 10 pontoons. Yes, I have 10 friends who I trust and love. And I was to ask them to radio back to me as my ship, as my boat, whatever, left the shore. I would say, please tell me how much the ship has gone down between mile 1 and mile 2, mile 2 and mile 3, mile 3, mile 4. And each of them in turn would say, well, it's dropping by 8 inches. Theoretically, I mean, obviously in reality we know that the water is level, but in theory, that it's dropping by 8 inches. Okay? I hope you're following me on that. And I'm sure a lot of people who looked at this formula a few years ago would have gone, you know what, I can't see how that formula of miles squared can work. And now I'm starting to understand why those people were smarter than, or at least more alert to this, and weren't maybe so drawn into the miles squared deception. Because each of them is going to say, at my mile to the next mile, or the mile before me and the next mile after me, it's been coming up 8 inches and going down 8 inches, going up and down, up and down. Okay, obviously that inscribes level. That inscribes level, but let's just work it from the beach out. And you've got 10 pals at a mile apart, and they're all reporting 8 inches, then you're talking about 80 inches of curve in the ocean. In reality, according to what we say at miles squared, you are going to encounter. Well, that's wrong. Obviously, that's wrong. It will never inscribe a ball. And when I first looked at this back in 2015, I was like, no, it can't be just 8 inches, because obviously that would be the most gentle of slopes. And someone in my comment section said, even at 0.6, a 1 for 0.6 ratio of drop, you're only ever going to describe a sort of slope, a very steep slope. Well, I think again that's because if we plot it on a graph and we only use the straight line out 1 and down 0.6, then yes, it's only ever going to do that. But we're actually using a piece of string from a radial point. And we have to travel 1 unit and go down 6 units, or 0.6 of a unit. So, you see, I can see why the 8 inches per mile squared starts to kind of look a little bit feeble, because I am demanding that the ship 10 miles away has dropped by 66 feet, because I said 10 miles squared, right? 8 inches squared, miles squared. So my friends, however, who I trust and love, are saying, no, Dave, it's only 80 inches. We can assure you it's only dropped 8 inches between my pontoon and your next best friend. So imagine now I've got 500 good friends who are all on 500 pontoons 1 mile apart. The 499th friend will say to me that the ship, getting to the 500th marker, has descended another 8 inches, and a total, therefore, of 4,000 inches across the 500-mile track. My 8 inches per mile squared would say the number, I think was 16,000, but I'm not interested so much in the total at this point in time. I don't have the numbers with me. I'm interested in what my maths at 8 inches per mile squared demands, that the 499th mile to the 500th mile is a 660 foot, I think it's 666 anyway. It's a six. I mean, again, wouldn't that just be typical of this crazy system that they've fed us with this thing? But do the maths, and you'll find that between 499 and 500, using the mile squared mathematics, you've got a 666 foot perspective, from my perspective, drop. Now, which is it, friends? Is the ship going down 8 inches, according to my 499th best friend? Or is it that I'm standing on the beach and demanding that my view, assuming I could see that far, demands that it's another 600 feet drop? Well, neither of those makes sense to me anymore. I think that I haven't yet got the technical drawing skills to, it was never my strongest suit in school, to offer you the answer as to what happens after you get past the equator, because obviously it becomes like a negative. You start to tuck back in. A ball starts to tuck back in on around itself. But the point is that it's a perfect sphere in this conversation, and the amount that the sphere is going to, according to my friends, the ship is going to travel mile by mile, is always going to be the same amount. And actually, in truth, in your heart, you must know that anything, let's call it a ball of water, anything that travels over that ball of water is always going to experience the same amount of curvature. If my harbor is here in England and the next harbor away is 100 miles and it's in France, is my ship in the 99th to 100th mile going to drop 130 feet, as the math suggests, at 8 inches per mile squared? Or is it going to just drop 8 inches, as my 99th friend would demand that it has? Equally, when the ship turns back around, is it going to start again from zero and say the first mile now is 8 inches? Or would it be, it's 132 inches because Dave is standing on the beach back there 100 miles away, and he's demanding that his math says that it's 130 feet on that last mile from England to France. But when you're in France, you're saying, hang on. It's only 8 inches as I leave France going back to England. And then when I get to the last mile between France and England, that mile then will be 132 feet up or down or whatever. Obviously none of these are real, but I'm giving you the hypothesis of imagining life on a sphere. Again, the viewer perspective has got nothing at all to do with shape. The shape is what the shape is. That's cannot be altered by you or I. My perspective of it, the far distance I can see, yes, I get that, but not the reality. And we're asking people to look with their eyes for 5 miles or further, depending on what they've got, and then still imagine that they're standing on point A. Well, actually, their eyes have taken them to point B or Z, or Z if you're an American. So there's a bit of a trick that's been played on us, and not only that, because there are these laws of perspective and angular resolution, we have allowed ourselves for that to be used as a way of obfuscating what the reality would be. And the reality is that if it's a kilometer, a mile, or whatever, and you have to drop 0.6, a mile over the skin of the surface of my 1 inch or whatever, is going to always have the same amount of drop no matter where. I've got the 20 on the top position there, but if I was to roll that somewhere else and put the 5 on top, the top position, would that mean that it had a different formula or a different amount of curvature? No, of course not. It's going to have exactly the same amount of curving, no matter what position you start from and what position you measure from or end at. Again, I'll stress that I think where we've gone wrong is we've been measuring out on a graph paper, and that's not how it is in reality. And yes, I accept that at 8 inches per mile squared, you can go to 6,000 miles. You can get to the equator and say, oh, that reflects a 4,000 mile drop of height from North Pole to, or northern to the equator. I accept that maths works. But it doesn't. But it belies the reality, and the reality would be, if it was a sphere, there would be exactly the same amount of curve from start to finish, no matter where your journey started, no matter where your journey finished. Assuming it was you went driving over mountains and so on. It's obscene. I mean, it's insane, and what it is so much curvature actually. That you don't need to do a laser test. There's very little that you need to do to say, hey, the curve that according to them should be that for every 100 meters I travel over the Earth, I should have to be dropping down by, in order to live on this ball that's eventually going to go around and eventually going to go underneath and eventually going to come back out the other side, a diameter of 8,000 miles or a radius of 4,000 and a 24,000 circumference. You're going to have to drop down 60 meters for every 100 meters you walk over the skin. Not allowing for any mountains and any flat areas and so on. That would only exacerbate, or it makes it, I know it feels like a bit of a steep hill, but it is, because the truth is that if we were living on a ball, we'd be pretty much falling off the side of it all the time. There's almost no point, if you can imagine a large football, there's almost no point in which you're ever on a level surface at all. And not only that, the curvature is so extreme as to be immediately obvious to even the most inured person. And so what we've been doing is we've been offering people this 8 inches per mile squared, and it says, oh, well, over at 5 miles, it's 25 times 25, which is 400 inches. People are like, that's a long way away, and I can't see the ship, so I can accept that it's probably gone over some curvature. Well, you don't have to worry with that, friends, because all you need to say is, look, half a mile or half a kilometer, 300 meters. That ship should be over the bulge, or should be over the hump within 300 or 400 meters of your harbor. Less. It's so much curvature, and it's insane. It makes no sense. It doesn't work, and it blows any idea that we live on a globe. Well, I mean, obviously, I gave up on a globe back in 2015, but for people who still want to cling to this idea, cling to the side of the ball like an evolutionary Darwinian monkey, they will have to concede. If we can demonstrate this using, AutoCAD and other tools, we can demonstrate the insanity of such an amount of curvature. And then it's game, set, and match, as Jack said last night in a podcast I was doing with him. Which, by the way, he's coming on tour, and he and Lisa do need some support, so you'll be hearing more about me from that, trying to pump up their channel so they can get 1,000 subscribers, go live, and also generate some income to continue this fantastic work that they're doing and that we're doing to try and spread the truth around the plane, not around the sphere. So that's that. I think hopefully I've made the point that, it doesn't really matter. It doesn't really matter where you start from. There's always going to be the same amount of angle change or curvature and drop, no matter where you are. No matter where you are, where you start from. If I start from 19 and move my way up here, I've got this, or down, I've got the same amount of curvature or angle of aspect change, if you like, throughout the entire travel. It's not going to get increasingly steep. It sort of makes us look a little bit kind of like sheep. But I think, my friends, this might be a bit of a bullseye for the ballers. I mean, it'll kill their ball, that's for sure. It's a ball popper. And I'm sure why we were given this 8 inches per mile squared, because it's just a little bit too little to be sure about. But 0.6 for every 1, that's a globe killer. I hope that's useful, my friends. Let me think if there's anything else I haven't touched on regarding the formula. Yeah, I mean, I think what I can't do with my graph paper is plot 1 unit of movement for I can't plot 1 movement unit for every bit that I go down. I can't do that on a graph paper. It's not tidy enough. It's not accurate enough. I came close to getting something that, for the first half, for the first quadrant, came close. I was plotting, but I wasn't. To be fair, I wasn't able to plot this exactly right. So I wouldn't claim I've got it tied right down. I'm looking for people with AutoCAD that either I can use or I can get you to use to reconsider this. Because what we're doing is we're saying this. We're saying, here's my observer, here's my equator. This is the amount, 4,000 miles, that we've got to descend down, and we're working it out on that basis rather than this distance here, which is the longer distance, isn't it? This is the short distance, straight line. This is the longer distance here. And I think we've been working it on the basis of that. And not only that, yes, from the perspective of this person here, which is a very, very low perspective, when you're standing on the surface. The angle is, from this person's perspective, the angle is growing exponentially. So right here, it's very little, I get that. And right here, it's becoming, as you move into this quadrant, it is becoming exponentially steep relative to that. But this is a form of relativity that I thought we'd thrown Einstein out on to the dustbin. But this is a form of relativity that's been used to keep us in yet another trap, because the ship doesn't get relativity. The water of our globe, our imagined globe, doesn't have relativity to it. It is actually a physical, well, if it existed, it would be a physical, like this dartboard, it would be a physical amount of constantly bending, evenly bending line. Not this, this is growing exponentially and look at that. Because, friends, if you do it like this way around, you say, when this guy here at 20 was leaving the port at Burkina Faso or wherever, somewhere maybe Brazil, which would be obviously, but if they were leaving this point here, they'd say, but no, the inches per mile squared is down to 8 inches again for the first mile. Whereas this dude here, Mr. Relativity, Einstein, is saying, no, it's dropping off, as you can see. The drop between this mile and this mile is thousands of feet. Well, yeah, okay, from your relative position.